Hello, everyone. I'm Matt Wang from CertiK. It's my pleasure to attend this amazing event for the first time. And in the past 2 days and this morning, we have heard a lot of sharing on the EVM stack in the Cosmos. Today, I'm excited to share CertiK's insight on the EVM Cosmos convergence research from the security perspective. Okay. First of all, please allow me to spend 1 minute to make a brief introduction to CertiK, the largest Web3 security service provider. It was founded in 2017 by professors from Yale and Columbia University. And CertiK always provides novel and best-in-class security-focused technology to safeguard the Web3 industry. Additionally, CertiK is also an important advocate for Web3 policy, especially for the compliance landscapes in multiple regions. Here are some of our clients, spanning from a wide spectrum among the Web3 industry. Definitely, Cosmos is one of our most important source of clients. Here is our vision, that's to elevate your Web3 journey. CertiK is committed to serving clients for life cycle, from inception to growth to success. Yes, we can see that we can provide a comprehensive assistance for our clients during their journey into the Web3, from the venture auditing and then to the go-to-market. Okay, let's jump now to EVM and Cosmos convergence. I will elaborate it in 3 parts. The first one is the Cosmos EVM. The second is the EVM precompiles. The third is the layered architecture in the latest trend in this part. Okay, first let's come to the Cosmos EVM. Formally, the name that we can see that's the user mint or EVMOS in the past years, and we are glad to see that in this year, the EVMOS has been migrated into the Cosmos EVM, ending the long period of unsupport. As this pattern, that EVM acts as an ordinary application among Cosmos SDK, just like the staking or Spawn, etc., and it interacts with underlying consensus engine. The formerly the tournament currently, that's the name is CometBFT, where the ABCI interface is. And so there are 2 types of transactions. One is the EVM transaction, the other is the legacy Cosmos transaction. They are routed to the corresponding handler, and as depicted in the picture below. Let's take the EVM transaction, for example. First, it will be routed to the EVM handler, and then go through a chain of decorators, and then run messaging in the EVM. That is apply transaction, refund gas. Remember, refund gas, there is a key difference on the gas market between the Cosmos and the EVM. That is, the remaining gas will be refunded to the user after the successful execution in the EVM. So, based on this point, there are 2 major vulnerabilities disclosed in the past years. That's the theft of transaction fees, stealing gas while bypassing the user mint and handlers. The root cause of this lies on the misroute the EVM transaction to the Cosmos and the handler intentionally. Finally, they were both fixed by introduce 2 new decorators in the Cosmos decoration that to reject EVM transaction in Cosmos and handler, and then there is another way that's to disable the EVM message in the lasted authorization message field. Okay, let's go to the second part. As time went by, the EVM precompiles were introduced in the Cosmos to improve the interoperability between the Cosmos and the EVM. Unlike the EVM precompiles, we can see that they are only used to read the state. That is, they are stateless. But these precompiles that we can see, these staking precompiles, they are stateful, that they can ultimately mutate the states in the Cosmos states. Either, for example, for the staking states, the distribution states, and etc. So there are some issues due to the state inconsistency during the precompile execution. The first one is we call that the partial state transition. From this code, we can see that the EVM state could be updated in the stateDB commit method. However, the underlying part, we found that in an older version of EVMOS, that the other parts, the other states were not updated accordingly. Especially for example, for the bank precompile, we can see that the second output in the line of the code, it should be the stateDB object of the bank state, but it's shadowed. So that means that even the transaction, even the EVM state is updated correctly, while the successful execution and the underlying bank state didn't commit at all. So how about what happens if the precompile execution reverts? So the second issue is the execution reversion collection. There we can see that take the staking precompile, for example, the delegate function could be invoked by an EVM transaction, and then if a malicious user could modify the staking state by this external EVM transaction, but it will immediately revert these EVM changes without to update the underlying staking states. So the code has been updated to that. After the precompile execution reversion, the underlying state should also be reverted accordingly. And the third one, the partial state write by out of gas. Yeah, we can see that the precompiles could only require several thousand gas to execute, but there could be some issues that if there is not enough gas, and there could be some partial state writes under the stateful precompiles. So each of the run of the precompile should also run atomic to make this execution over the precompiles to be atomic. Okay. Okay. Let's quick go to the last one. This layered architecture inspired by the Ethereum mainnet. That there are two layers: the consensus layer and the execution layer. They can communicate with each other via the engine APIs. So how it works? We can see that there are several engine APIs between the ER and STIR and the interaction like this. And so there is an idea that, and we all know that CometBFT is the popular and the robust BFT consensus. So how about to replace the consensus layer by the CometBFT, but keep the execution layer the same as that, the EVM clients like the gas, RES, Arrogant, and something else. Yeah. So if there's some successful example here? Yeah, and the answer is that the barrier chain and the story IP protocol use this layered architecture. And most importantly, we can found that the ArcChain layered, backed by the CertiK, empowered by the Malek's layered architecture, will also use this layered, will be coming soon. Yep. So I think this may be the trend of the Cosmos and the EVM converging. Yeah. So there should be some adoption about in the ABCI implementation on the engine API. In the prepared proposal, that such APIs will be embedded in this in the prepared proposal API method, and for the process proposal, which will be used as the block validation, and the engine API, that the new payload will be sent to the EL for the execution payload validation. And for the finalized, during the finalized method, that this method delivers a decided block. Due to the CometBFT, we all know that the instant finality, there is low fork choice rule over there. So, however, finally, on FCU, the fork choice update still sent to the client, to the EL client to update the state, but there is no payload attributes over there. Yeah, and the last one is the commit that will persist the state with the chain generation. So let's take to a case study about if there's vulnerability over there. The first one is the inappropriate error handling in the process proposal. We can see in this code that if there is an invalid proposal, and there could be two approaches as the status reject or to accept. But if this error is not fatal, that it will be accepted. So there is a potential possibility that an invalid block will bypass the process proposal and then into the block finalization. And the second one is that this very sidecars method in the process proposal function, that there is a duplicate commitment KZGT, commitment detection logic here. It means that the malicious user could exploit this by issuing two similar blobs in one single EVM block, and then if this comes to the duplicate commitment detection, it will halt this process proposal, then can halt the whole chain to produce the new block. Okay? Okay, for more details, please refer to our series of blogs in our homepage. That's the EVM Cosmos Convergence research from security-based part 1, 2, and 3. Okay, I think that's all of my presentation. Thank you for listening. Always, CertiK is always a committed to elevating your Web3 journey in Cosmos. Thank you all.